Wax precipitation and prevention in CO2 producing wells. Progress report presentation. Team members Derek Axelson, Justin Kay, Ellis Rech, and Jacob Sullivan. Faculty advisor and gatekeeper Dr. Mehdi Zayduni. The purpose of our project is to gain a better understanding of paraffin and asphaltene precipitation, specifically in CO2 producing wells using CMG and WinProp modeling software. Ultimately, we hope to provide performance recommendations to develop key performance indicators that can be used in the prevention or reduction of paraffins and asphaltenes. This figure shows our original workflow and time frame proposed in our charter presentation. So far, we have completed our initial literature review and have acquired a large amount of background and tutorial information from our contact at CMG. We are currently filtering through the information provided by CMG, researching inputs, and beginning to learn the software. The following slides will outline in more detail the work that has been finished up to this point and the work planned over the coming weeks.
From our contact at CMG, we have received additional SBE papers on modeling asphaltene precipitation, multiple WinProp data templates, and various example case studies ran by CMG using the WinProp software. We were given over 150 pages of documents related to the use and execution of WinProp, along with other software that could relate to our project. This information will be paramount in being able to successfully model the reservoir fluids and the deposition of wax and asphaltene. CMG's goal was to develop WinProp as a user-friendly model with a small number of adjustable parameters to practically and efficiently simulate asphaltene and wax deposition. The SB papers we have received specifically highlight the fundamental calculations used within this user-friendly model. By reading and understanding the literature using the WinProp software, we will become more educated on the deposition of paraffin and asphaltene and the equations of state used within WinProp. Having a firm understanding of these base calculations and using the case studies as our tutorial guides, we are currently familiarizing ourselves with navigating within CMG and discovering its full capabilities. Moving forward, we hope to develop a high level of proficiency within WinProp throughout our project.
WinProp is an equation of state modeling tool for accurately describing phase behavior of fluids in the reservoir. It is a high-level calculation engine that uses fluid property inputs to predict fluid behavior. In our case, this behavior is the deposition of wax and asphaltene. The use of WinProp allows operators to understand the phase behavior of the reservoir to pinpoint potential problems so that solutions for mitigation can be determined before a problem begins or so a current problem can be remediated. The picture on the left shows the WinProp screen, and on the left-hand side are the interfaces for inputting fluid and reservoir properties that are then used to calculate, characterize, and model the state of the reservoir fluid. We will mainly be using the asphaltene and wax modeling interface. Here are a few pictures that only scratch the surface of the modeling capabilities within WinProp. On the top left, there is a liquid phase mole percentage versus pressure curve for multiple temperature points. The top right shows liquid viscosity versus pressure curves. The middle bar graph shows liquid components, and the bottom left is a ternary diagram. As seen here, WinProp is capable of modeling the changes in reservoir fluid while including all appropriate parameters. The modeling capabilities of WinProp will give us our results and deliverables along with key performance indicators in the flow assurance of the reservoir being modeled.
The main purpose of our project is to understand the actual depositional problems which occur in the Delhi field in northeast Louisiana. Specifically, we want to understand asphaltene deposition which occurs in the Holt-Bryant Reservoir, which consists of both the Upper Cretaceous Tuscaloosa and the Lower Cretaceous Paluxy sandstones. The field in question is currently being operated by Denbury Resources and has undergone primary and secondary production and is currently undergoing tertiary CO2 flooding. As seen on the right, we have already acquired general fluid properties data for this field. We are using this information to run our initial WinProp simulations. Once we feel proficient using the WinProp software, we will gather needed well data from our industry contact at Denbury and begin working on a more finalized model. So, in conclusion, we have stuck to our project timeline and hope to have a finalized WinProp deposition model by either February or March. From there, we hope to gather results and deliverables, and from those results and deliverables, we hope to develop key performance indicators for implementation in the actual field in Delhi, Louisiana.